All right. Well, welcome everybody, and thank you for coming to today's class on maintaining garden and raised bed soil, the soil and plant relationship. My name is Lynn Trulio. I'm a proud 2024 Master Gardener graduate, and we have other volunteers here today who are helping with this presentation to make sure we have a nice, smooth experience. Our volunteers are Karen Hill, Catherine Frazier, Kathy Trafton, and Barbara Williams-Sheng. We want to thank you all for helping today. I also want to thank those who agreed to participate in a follow-up survey to this class. It's conducted by the State Master Gardener Office, and the results from the survey are used to measure the effectiveness of our classes and always to help improve the experience for everyone who joins us for these types of classes. A few words about the Master Gardener program. The UC Master Gardener volunteers are trained and certified by the University of California to provide valid research-based information on home horticulture and pest management. Our goal is to help home gardeners and community organizations garden sustainably and create a healthy environment. We're glad you're here to join us for this today. It's my pleasure to introduce our speaker, Terry Lyngso. Terry Lyngso is a lifelong gardener, master composter, UC Master Gardener, and a student of the soil food web. She's also a lover of the natural world. Her garden in Loma Mar is a waterwise native garden that she and her husband designed, planted, and maintained. They also grow apples, herbs, and vegetables. Terry is president of Lyngso Garden Materials, a 60-year-old family business located in San Carlos. Before we start, I wanted to say that we will welcome your questions, but we want you to put them in the chat. About a third of the way through, Terry will stop and answer questions that are in the chat. She will also answer questions at the end of her presentation. Again, please put your questions in the chat. That way we can get to them all. This presentation will be recorded and will be available in the future on our Master Gardener YouTube site. So now I want to welcome Terry Lyngso. We are so fortunate to have her today to share her deep knowledge. Terry, take it away.
Thank you, Lynn, and thank you, Master Gardener team, for supporting me here. And welcome everyone to my talk on maintaining garden and raised bed soil, the soil-plant connection. And I'm very excited to be sharing this with you. Why isn't it advancing? Okay, sorry. So I'm really excited about this. The soil and plants work together, and I hope in this presentation to be able to share with you that relationship. So I'm going to be actually starting out with just what is soil. I find people are very confused about what is soil. And then soil compaction, it's a huge problem for most urban gardens, and kind of contrast that with biological soil structure, which is our goal and what we want to build in our garden soil. And then the soil-plant connection, plant needs, maintaining garden and raised bed soil. Go over a little bit about mulch and soil amendments, cover crops, feeding the soil, a little bit on soil tests, and then I always find it really important to talk a little bit about how to plant a tree, a bush, or a shrub. I think there's a lot of confusion there. And then I'll go over some examples of gardens. So jumping right in, what is soil? Well, just take a look at this diagram here. And isn't it amazing that 50% of soil is essentially empty space for air and water? I think most of us had no idea that there was that much space within soil. And this is soil that's biologically active, alive. And so 45% of that soil is the minerals, the parent rock material that have been broken down over time, the sand, the silt, the clay. That really, in a healthy soil, is only about 45% of of a volume of space of soil. And then 3 to 5% and more, it could be more, is organic matter. And this organic matter is the living organisms in the soil, as well as living plant roots, and then everything that has died in the soil and is being broken down and recycled, and all the byproducts from the biology and it from the microbes. And this microbial community is who actually builds the structure to create the space so air and water can move into your soil. Your soil needs to breathe. So let's just go over a little bit about texture, because people get really confused between soil texture and soil structure. Soil texture is simply the percentage of sand, silt, and clay in your soil, in your parent rock material. And you can have this tested in a lab. I also, in the resource section, I have a few home tests that you can do to try and identify the texture of your soil. Sometimes you can just tell by feeling it. So sandy soil will be you will actually visually see the little particles of sand. The individual particles feels very gritty, drains very fast, and it doesn't hold on to nutrients. And you pretty much know if you have sandy soil, you water and it's gone. Silt kind of looks like dust. It feels slippery if you're walking on it. If it's wet and you're walking on it, sometimes your feet will slip out from under you. It drains much slower than sandy soil, and it does not dry out as fast as sandy soil. It will compact, and the smallest particles in silt have a cation exchange capacity, and that simply means that soil is, those particles are so small that they can actually hold on to elements. So you can think of it as the cation exchange capacity is kind of like your little savings account for nutrients in the soil. And then clay particles are so very, very small, you cannot see them. They feel sticky when wet. When they dry out, clay soil is very, very hard. It's slow to rehydrate. It also drains very slowly because of the small size, and it compacts really easily. So you really want to be very careful with clay soils and not work them when they're wet. And it has a very high cation exchange capacity because those little clay particles are so tiny, and they have a negative charge to them. And so they can hold on to positively charged elements like calcium, magnesium, and potassium. So let's just take a little look at practices that create soil compaction, because I think most of us in urban gardens, soil compaction is not unusual. And all soil compaction means is that that mineral portion has been squished down so that the space is much reduced. Generally, there's lower organic matter in compacted soil because usually there's not a lot of plants growing in compacted soil. Things that create compacted soil are the leaf blower. So I really encourage you not to use a leaf blower on your soil. It's fine for hardscape, but when you put a blower on the soil, it's blowing the mulch away. It's blowing everything away, including the organic matter. So don't use a leaf blower on your soil. Repeated tilling and turning of the soil is also very hard on the soil biology. It breaks down all those little homes they've built, and it creates compaction. Fertilizing also can create compaction for other reasons, which I'll go into a little bit later. So really do not over fertilize. That's very important. And biocides, meaning fungicides, insecticides, herbicides, all create compaction in the soil because they limit the microbial growth, the microbes in the soil. They really do limit their ability, their diversity, and their numbers. And when you have compacted soil, rain and irrigation water cannot infiltrate, it tends to run off. So water is not held deeper in the soil. There's limited gas exchange. The air your soil cannot breathe. And with reduced moisture, or maybe too much moisture because it's very compact and the water can't drain out of it, and limited gas exchange, that also limits the diversity of life in the soil. And any plant roots growing in it are going to struggle a little bit more. And generally, organic matter is very low in compacted soil, usually 1%, less than 3%. So practices that build soil structure and create all that space is, protecting your soil from the elements. The sun, the wind, and the rain are really, really hard on soil. A raindrop hits the ground at 20 miles an hour. That's amazing. I was amazed when I heard that. And so raindrops over a winter season can really create a lot of compaction in that soil. The sun heats up the soil and moisture evaporates from the soil, so it's actually pulling the moisture out of the soil. And then the soil dries out and the wind blows it away. So your soil needs to be protected with a mulch cover. And in nature, think about nature. Nature does a very good job of protecting the soil with mulch. Everything that falls to the ground stays on the ground, gets broken down over time, and supports the microbial community underneath. So keeping soils covered with mulch or with a plant cover is really good. Now, one thing I do want to say is we do have a lot of native bees in California. We're very, very fortunate to have lots of native bees, and many of them are ground nesters. So do leave a place in your garden where you don't have mulch, maybe underneath some plants, and the bees can do their little ground nesting there. So applying compost to the top of the soil, just a small amount even just 3/8 of an inch, will provide life as well as nutrients. Very thoughtful use of fertilizers, and I really encourage you to really use organic fertilizers. I'll be talking more about that later, because organic fertilizers do not feed your plants directly. They're feeding the microbes, and the microbes are feeding your plants. And then finding natural alternatives to biocides. And a lot of those natural alternatives are the beneficial insects that we really want to see increase, and we really want to invite into our garden. I'll be talking a little bit more about that later too. So when we have that good soil structure where half of that space is open for air and water, then rain and irrigation water can move into your soil easily. It does not run off. And your soil actually becomes a reservoir for water over time. And in California, we have a long drought season, a long dry season, and having water in your soil held in these small pore spaces is extremely beneficial to your plants. They have access to water over the long season, and you don't have to irrigate as much. When you have living soil, you've got a diversity of beneficial life in the soil, and that diversity of beneficial life actually supports the health of your plants. So your plants are much, much healthier. The organic matter starts growing in your soil, and you will find that you may have 7, 8, 10% organic matter over time, which is really great. So nutrients are cycled to the plant back and forth and stored in the soil aggregates and also within the microbes that live in the soil. So the soil plant connection, I love this slide. This slide is from Earth Fort. They are a lab up in Oregon, and they actually measure the life of the microbial community in your soil. And, you know, it's all about plants and it's all about microbes. And the plants have an amazing ability to take the carbon dioxide out of the atmosphere and using energy from the sun, break that bond between the carbon and the oxygen. And they use that carbon not only to build their bodies, but to create a recipe of all kinds of exudates, liquids that they release out of their root zone. And that feeds the microbes. And those exudates are very specific to what the plant wants and needs. And so it's calling in the microbes that can best gather nutrients in the soil and bring them to the plant. The bacteria and the fungi are the foundation of the soil food web. They break every single thing down that falls to earth. And the fungi, the mycorrhizal fungi, which are the fungi that form a relationship with a plant root, that mycorrhizal fungi actually can go out and bring water to the plant. It can bring nitrogen to the plant. It can bring phosphorus to the plant. And in return, the plant is feeding that fungi so that it can have lots of carbon. Because remember, only plants plants are able to get that carbon out of the atmosphere, and the fungi is able to build their bodies out of that carbon. And fungi are a great source of carbon in the soil. Then I want to draw your attention to the sky and the N2 in the little boxes there falling down to the ground. Okay, when your soil breathes, it's breathing in the atmosphere, and that our atmosphere is 78% nitrogen. That nitrogen, there's two nitrogens that are bonded together in a triple bond, and that bond is so tight, and nobody can use the nitrogen in that bond. But there are free-living bacteria and bacteria that live in root nodules that are able to break that bond and then mineralize that nitrogen and make it available to other life in the soil and to the plants. So I know we all, you know, I think most people worry about, I got to get more nitrogen out to my plant. But really, if you've got a good biological structure in your soil, those microbes and that plant are working together and it may be getting all it needs. You can, if you have a good biological structure, you don't have to do so much. You just have to make sure that you don't do things that that destroy the homes of the microbes. And think about nature. I mean, in nature, no one's feeding a redwood forest, no one's feeding an oak grove. That's all being done between the life in the soil and the plant itself. So I really encourage you to take faith in that microbial community and its ability uh, to care for your plant and your plant's ability to care for the microbes. So I thought I should show you a picture of biological soil structure, and I think any of you could go out into your garden, maybe in maybe under an oak tree if you've left the leaves over the years just build up under your oak tree. Somewhere where you've mulched over the years, pull that mulch aside and pick up a handful of soil. And that's what I did here. And this is magnified a little bit. So what you'll see, and this happens to be in the winter, so it's a little moist, you can see how the soil is bound together into clumps or aggregates, smaller granules and then larger larger clumps called aggregates. And that's the bacteria and the fungi that are doing that, that are gluing that and binding it together. And you can see all those dark areas. That's the pore space. That's where the air, that's how your soil breathes. That's where the water moves in. That's what you want to be looking for in your soil. And that will happen in your soil over time, I promise. And another really interesting thing is the microbes are able to clean water as it moves through the soil. So you'll notice a lot of areas now in our area have bioinfiltration areas or planted areas alongside parking lots. And the rainwater falls on the parking lot and that water drains out into the bioinfiltration area. And the microbes clean that water up before it, as it moves down into the soil and moves out into our storm drains. So they do a lot of really important work for us. I know this was an involved section here, and so I really wanted to stop and see if there were any questions.
Terry, currently no one has put a question into the chat.
Okay.
So if we don't, we could give it another few seconds, but if we don't get any questions, you could proceed if you'd prefer.
Yeah, well, why don't I just go ahead and proceed, and we will have time for plenty of questions at the end if there are questions. I look forward to hearing from people. So, really important, absolutely necessary, is for us to understand the needs of the plants in our garden. Really isn't negotiable. And I know, we all have stories of wanting a plant and trying to get a plant to grow. But if you're not addressing the needs, the plant is just not going to succeed. So, sun, how much sun that plant gets and the time of day of the sun, what kind of drainage they need. Do they need really well draining soil, or can they handle a little, slower draining soil? Do they need constant moisture, or can they dry out a little bit? What about the pH of the soil? Some plants are very particular about that, and the pH of the soil has a big impact on on the availability of the solubility of nutrients in the soil. So those are all really, really important, and you really owe it to your plant to understand that before you put your plant in your garden. And then the needs of the plant also inform what kind of garden care you provide to your garden. So natives and many perennials, they really need a microbial community. They need that biological soil structure. And a lot of them really need that a mycorrhizal relationship, that relationship between a fungi and the plant root. And oftentimes they really don't appreciate fertilizer and definitely don't want animal manures. The mycorrhizal fungal relationship for a lot of us living, I think, if you're living close to wildlands, we have a lot of wildlands nearby us in San Mateo County, not so much maybe in San Francisco. But if you have a mature oak tree or mature trees nearby, you might have mycorrhizal spores in the air. So I'm not sure that you really need to do inoculation, but it's just important for you to know that for many of our natives, they really appreciate that relationship. And they don't want a lot of fertilizer. And many of them do want mulch. Veggies and heavy feeders like roses, they also need a microbial community, and thoughtful soil care in spring and fall of compost and maybe even organic fertilizers. I'll be talking a little bit more about that later. So let's jump into maintaining garden soil. As I said, you really have to protect the soil from the elements, from the sun, wind, and rain. And this can be done with mulch. It can be done with plant cover. It's really important to create and maintain pathways in your garden, because walking on your garden does compact the soil over time, especially if it's a very active area. So consider that. And if your soil is very, very wet and has a fair amount of clay in it, a lot of traffic in it, will create compaction over time. Uh, Nutrients, really feed the soil, not the plant. Really start thinking about that. And organic fertilizers, they're called organic fertilizers because they have carbon attached with it. So that carbon then provides energy to the microbial community, and then you have essential elements in that fertilizer that the biology breaks down and makes available to the plant. Compost, leaves, wood chips, bark, they're all food. Compost will provide beneficial life as well as soluble nutrients. Leaves, wood chips, bark are all protection and food. As they're broken down, they become food. So I really, sort of want to stress that mulch is not just protection, it's also food. Grow your soil structure, and so really avoid biocides. If you have weeds, do cut them down before they bloom. And weeds actually, are kind of nature's healers. I mean, they're putting massive roots into the ground. They grow really fast, and they're helping to open up that soil, and they're helping to get organic matter in the soil. But we don't always want weeds in our garden. So the best thing is cut them down before they go to seed. And then to avoid biocides, really pay attention to beneficial insects and start inviting them into your garden by planting plants that will attract them. And the Master Gardeners on their YouTube channel have many workshops on beneficial insects and how to attract them. And I really encourage you to do that. It's great fun to get to know them, start paying attention to who's in your garden, and instead of being all worried about everyone, get excited about it and see what you can do to make a change just by planting a little differently. And water, really appropriate for the needs of the plant. So do check your irrigation system. Do not overwater. Overwatering is a huge problem and a fairly common problem. Do irrigate outside the drip line of your plant to encourage root growth out beyond the drip line. You want those roots to move and move deeper and move farther into the soil, and you need the microbial community to support them, and that microbial community needs moisture. And then look for puddling after rain. This can be an indicator of compaction in your garden, so that could be an interesting indicator for you. So watch for that. Raised beds. Okay, so raised beds, first of all, I have to ask you, is the raised bed on pavement or is it on soil? If the raised bed is on pavement or a solid surface, then it really is more a container. If it's on soil, then it's a raised bed, because a raised bed, you want those roots to actually go as deep as they want to go. And so putting a raised bed on top of your existing soil, you really want to encourage those roots to go down deeper should they want to. Consider if you're willing to grow all year. That's really important in a raised bed, to have a plant growing all year long. Think about your neighboring tree roots. Some trees can be incredibly invasive. Some of the ones that can be common ones around here are liquid amber, maple, redwood, eucalyptus. They will very, very, very quickly invade your raised bed and it will become a solid mass of roots. So do try and keep your raised beds away from trees that have roots that may be looking for moisture and nutrients. And then also consider over time if your raised bed will meet the plant's needs for sun. And then also consider organic or synthetic. And I think, as you've seen, I really, really encourage organic, because with organic fertilizers, you are going to be feeding the whole community, not just the plant. And that community is going to be responsible to a large degree for the health of your plants. And that can be very freeing knowing that. I know when I first learned about the soil food web, I was like, oh, wow. Okay, I don't really need to know all the details. I just need to support this community. So again, it's really important to understand raised bed soil. And generally, there's, this is probably a pretty good recipe for a raised bed soil mix. It should be between 33 and 50% mineral. This is your sandy loam, loamy sand, or even clean topsoil from your garden if you know it's clean and it doesn't have too much clay in it. You probably prefer not to have more than 10 to 15% clay. Additional minerals are things like lava rock, perlite, vermiculite, pumice, pea gravel. They all help with drainage in a raised bed, and you can use them in combination with your sandy loam or loamy sand or topsoil. So that should make up about a third or a half of your soil. And then the other third or half should be mixed, which should be finished compost or compost and worm castings, and a blend of a woody material like a quarter minus fir, redwood sawdust, lignite peat, or coconut coir. Those would all provide a nice carbon source. And remember, everybody needs nitrogen and everybody needs carbon to grow. So carbon is really food for the microbes. And then an organic fertilizer may be appropriate depending upon what kind of compost you're using. So choose one appropriate for the plants you're growing. I'll be talking a little bit more about that later. So raised bed maintenance is critical, and I find there's a lot of confusion here. And so you may have a raised bed soil mix that perhaps you bought, and I always encourage you to understand what's in that soil mix. Many soil mixes are 33 to 50% mineral. That mineral is not being digested or broken down by the microbial community. So that mineral is going to stay there in that soil. But what is broken down is all that organic matter. That organic matter is being digested by the microbes in the soil, and the level of your bed is going to drop over time because it's digested. It's gone. It's outgassed as CO2 and used to build the bodies of the microbial community. So you need to replenish that organic matter every year, and it needs to be replenished 2 to 3 times a year. Usually it's sufficient just to spread 1 inch over the top of your raised bed once or twice a year. You can use something like a pitchfork or a garden fork and open the soil up a little bit and let that organic matter move down into the spaces that you've created. Another way to feed your soil is to leave the roots in place. When you're removing your annual veggies, you can simply leave the roots in place. They're food for the microbes. If you're going to plant again and there's roots in the way, well, then you can move them out of the way. If you decide that you are not going to grow an annual crop all year long, or flowers or whatever it is you want to do in your raised bed, if you're feeling like I just don't have time right now, I really encourage you to plant a cover crop, because that plant those plants, are providing all that liquid carbon to the soil, which is a great benefit to the microbial community. And that will help maintain your soil structure and keep the diversity of your microbial community going. But if you simply just cannot do it, then do cover your raised bed with like a 1/2 inch of compost and 1 to 2 inches of mulch to help prevent compaction from the sun, the wind, and the rain. Do not leave the soil bare, exposed to the elements. And I can't tell you how many times I've had people say, oh, especially in, I hate to say it, in some school gardens, this was years ago, I think it's better now, but the advocate for the garden would be gone and nobody would be paying attention to that bed during the summer or maybe during the winter. And then they would go like, well, this soil is terrible. Well, it's only terrible because it was neglected and the organic matter is gone. And where you end up being left with is sand, silt, and clay. So do take care of your raised beds. Sun. Sun is amazing. We need the sun. The plants need the sun, but it can be really, really hard on the soil. And you may have experienced hydrophobic soil. This is where water beads on top of the soil instead of moving into the soil. It can bead on top of organic matter. I think it can bead on top of sand and silt. And I don't have clay on there, but on clay as well. It can be very, very difficult to re-wet these materials. There's a as the microbes are decomposing the organic matter, there's a waxy layer in the soil solution that can spread around the organic matter and the sand, silt, and clay in the soil. And the sun, as we know, the sun beating down on the soil evaporates the moisture from the top layer of the soil, and so water is repelled. Don't worry, you can re-wet it by applying the water slowly over time and it will rehydrate. But mulching can really be a big help in this instance. And these are photos from Nick Landolfi. And what he does is he just grinds up the leaves in his garden and applies them as a mulch over the top of the soil. So a thin mulch over the top of the soil will really help. And we had in our home, we had a south-facing slope, which when we moved there was loaded with weeds. We knocked down the weeds and we did we put 4 inches of mulch on top of the slope. Well, as the fungi, the saprophytic fungi are breaking down all that dead plant material and breaking down the mulch, over summer, it becomes very hydrophobic. And during the first rain, the water was kind of beating on top, but eventually it went through and everything was fine. So, don't worry too much, but do consider a mulch if you're seeing a lot of that, especially in your raised bed or garden. So organic mulch. Organic mulch just means that it was once alive, and this is everything that falls to the ground. And when you go into a forest and you walk on the soil, and it's very, 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 very spongy, and it feels kind of bad once you know this to walk on it because you're squishing all those little homes of the microbes. But organic mulch will be broken down by the community, the microbial community, and it will be mixed in with that top layer of soil. It will be mixed in with the sand, the silt, and the clay. And this image here is an area underneath a canyon oak where we pulled the mulch aside. So you can see the leaves of the canyon oak. And then as you look farther down, the leaves are less discernible as leaves, more as organic matter. And then you see the fungal mycelium, that white mycelium there. That's the fungi breaking down the organic matter in the soil, in the mulch. So as I said, mulch is definitely food for the microbial community. It protects the soil from the sun, wind, and rain. It helps the soil retain moisture. It keeps the soil cooler. And it really does a pretty good job of preventing, especially annual weed seeds from germinating. Some things like bindweed and blackberry, no, mulch doesn't help so much there. So that is a whole other topic of conversation. Then there's mineral mulch, and this is pebbles, rocks, gravel, rock fines. They will also provide protection from the sun, wind, and rain, and conserve some moisture in the soil. But they really are not food for the microbes. They're not going to decompose. However, they definitely will sink into your soil when it rains, and weeds can germinate through them, and they also can hold on to some heat. So, but there are some plant communities that really appreciate a mineral mulch, and so that's why, at the beginning, a while ago, I said really understand your plant's needs, because some plants are going to want more of a mineral mulch than they are going to want an organic mulch. One thing I have to caution you on is weed fabric, very popular, been around for a long time. The weed fabric nowadays has holes in it, so supposedly water can drain through it, but it can be a real nightmare to use a weed fabric under a mineral mulch. The weed fabric over time does get brittle and will break down, and we do not need any more plastic in our soils, or really in our world. So I really do discourage the use of weed fabric, but it does make mineral mulch a little bit more of a challenge, and you need to be very, very careful about where you choose to use it. Okay, back to organic matter again. So this is organic matter in terms of compost and woody amendment. And I'm doing just a little comparison here to make you aware of the carbon to nitrogen ratio. That's a really important ratio that, we really should understand a little bit. Carbon is really, really important, and so is nitrogen for life. And so, for instance, bacteria need about 8 parts carbon to 1 part nitrogen to build their little bodies. And they're going to grab that carbon and nitrogen from anywhere in the soil to build their bodies. So in nature, everything's being cycled in a balanced way, so it's not so much of a worry. For us in our home garden, if we apply a lot of woody amendment and mix that into our soil, we may end up with a very high C to N ratio. That means that the microbes are going to use every drop of nitrogen in that soil to build their bodies, and it's going to make it a little bit harder on the plants. So then different kinds of wood have different C to N ratios. So redwood, as we know, is very slow to decay. I mean, some people have redwood raised beds that are 20 years old and they're still just fine. The fungi has not broken it down. There are redwood shavings available, and they're going to be a lot slower to break down in your soil, and you're going to want to mix those with a really like an animal manure compost would be good, which has a lower C to N ratio. And then fir bark is broken down a little bit faster than redwood, so it'll be a faster source of carbon. Lignopede happens to be the bark of redwood trees. This comes from the lumber industry, and it's ground up. It is considered a substitute for peat moss. It isn't quite as acidic as peat moss, but it is a preferred preferred to use something like that over peat moss. Really recommended not to use peat moss. Peat moss really should stay in peat bogs. I talked a little bit earlier about compaction in a raised bed and using a broad fork, a pitchfork, or a garden fork. And here's a little bit, this is an alternative to rototilling, because rototilling might be something you do one time if you have very, very compacted soil. You can do a one-time rototill with, 2 to 3 inches of a compost or a compost and a woody amendment mixed together into your soil. You only want to do that one time. If you've ever watched a rototiller work, it's incredibly destructive of any soil structure. So a more gentle way is to open up the soil using a broad fork, a pitchfork, or a garden fork. And it's very simple. Just every 8 to 12 inches, you just insert it into the soil and rock back and forth and lift a little bit. And then you can spread the compost over the top and water it in. And this is a much gentler and kinder way of working with the soil and supporting the life in the soil. Sheet mulching is also another way to build soil structure, and you can use it to eliminate turf and many weeds, especially annual weeds. Sheet mulching really needs to be done right. There are if you don't do it right, you will have problems. And the most important thing that you need to remember if you're going to sheet mulch with cardboard or with paper is that you have moisture and you have good connection between the cardboard or the paper and the compost or the soil. If you have air gaps in there, that cardboard is not going to break down and water is not going to be able to enter your soil. So sheet mulching can be a real disaster if you don't do it correctly. But my favorite way, and what we did a lot at our home, which was when we moved there a long time ago, it was all it was weeds, pretty much weeds. And so we chopped down the weeds before they went to seed, and then we spread a little, we wet the area and we spread a little bit of compost over the top, and then we did 2 to 3 inches of mulch, and we went through the winter rain. And we came back in the spring and we were able to start planting our garden. And that worked very well for us. Cover crops, I really recommend that you go to the Master Gardener YouTube channel and listen to Kathleen and Lisa Putnam's talks on cover crops. They're amazing. They're so knowledgeable. And I'll be showing you a slide later on of Lisa's garden at Mission Farm. But cover crops are really important way to build soil structure, to cycle carbon to the soil, to increase your microbial community, to increase the organic matter in your soil, to really grow your soil structure. Prevent compaction, ensure that the water infiltrates and is stored in the soil, so your soil is actually a reservoir for water. And with this plant community on top and diverse plant community, and then the microbial community below, you are just building this great diverse system to help your plants be more disease and pest resistant. And the cover crops that you choose to grow can also call in beneficial insects and pollinators and support them. So I really encourage experimenting with cover crops if you're thinking of going fallow for a year in your vegetable garden. So remember, I feel like in California, a lot of it is about water. Water is precious, and soil compaction limits water infiltration. And that is, leaf blower, foot traffic, repeated tilling or turning of the soil. too much organic and inorganic fertilizers, biocides, the elements, the sun, wind, rain, no plant or mulch cover. Your rain water is going to run off along with some of your soil. This is called erosion. But with biological soil structure, you're increasing the soil's ability to infiltrate water and to hold water. So by feeding the soil, not the plants, you're building that soil structure. Leave the leaves or mulch. Do save places for your little native bees. Apply compost and mulch, cover crops, plant cover, and really allow rain and irrigation water. Allow your soil to be a reservoir for water. So let's go in really quickly through what does it mean to feed the soil, not the plant. As I talked earlier in that great slide from Earthfort of nitrogen sources, and that the atmosphere is 78% nitrogen, that's reason alone to want to make sure that you have a good soil structure and diverse microbial community, because they are taking that nitrogen out of the atmosphere and they're making it available. Organic fertilizers can also supply nitrogen, and as I mentioned, organic fertilizers contain carbon, which is really important, because then you are feeding you are giving the life in the soil what they need. They need that carbon as well as that nitrogen. And sources are alfalfa meal, fish meal, feather meal. So organic sources of nitrogen support soil structure. Synthetic nitrogen is taken up directly by the plant. It bypasses the plant community. It goes into the soil solution. The plant takes it up. It can be very easy to over-apply it, and the plant can only take up so much. So excess nitrate moves easily with water, and it moves deeper into the soil. And as we know, in agricultural areas, the groundwater can be so contaminated with nitrate that they can actually use it as a fertilizer. Synthetic nitrogen feeds the plant directly and does not contain any carbon and does not support soil structure. So here's some examples of organic fertilizers that feed the microbes and let them feed the plant. And I have on the under single source, I just have broken them down by nitrogen, because that seems to be everybody's big worry, but I don't think it's as big a worry as it needs to be. And I just want to point out that the first number there is nitrogen, the second number is phosphorus, and the third number is potassium. And these are the nutrients that the plant uses most. However, the plant needs everything, including the micronutrients. I just want to point out that blood meal is a really fast source release of nitrogen. The biology is able to break that down very, very quickly. Feather meal is broken down much more slowly. So it's kind of interesting. I just throw that out. Then there are organic fertilizer blends specifically for the type of crop that you're growing or plants that you're growing. And so that might be a better way for most gardeners to go, is to, if they feel they really need a fertilizer, go with the blend appropriate for the plant. Liquid fish and kelp is a good fertilizer. The fish will actually be supplying not just nitrogen, but actually amino acids and protein. And the kelp has many, many minerals in it. And the kelp, it's important to note that it's good to get your kelp from people who are farming it from the cold waters on the East Coast, and they're hand harvesting it. So make sure that your kelp is certified, because you don't want to be damaging kelp forests. And then there's biological. This is biologicals. This is beneficial bacteria and mycorrhizal fungi. There's all different. There's granular and there's soluble, and As I mentioned earlier, do you need them? Don't you need them? I don't really know. It depends on where you live. Fungal spores are everywhere in the air. So if you're in near some wild lands or near some mature native plants, you probably don't need it. You've probably got it. If you are, so I'll leave it there. I do not, I have actually never used an inoculum, but I'm sure there are master gardeners who have and could talk about it. Compost extract is kind of interesting. If you have a really well-made compost, if you make your own compost, like Johnson Sioux bioreactor compost, that is going to have a diversity of life in it, as well as some soluble nutrients. And so you can make a compost extract just by a 5-gallon bucket filled 2/3 of the way with water and 4 cups of compost in a paint strainer bag. Massage gently for 60 seconds or more until the water turns a dark brown color. And then water that into the root zone of your plants, your potted plants, and even onto bare soil and cover with mulch. So you're kind of doing an inoculation of life and also supplying some soluble nutrients. Soil testing. Okay, so you will see all kinds of recommendations online for what to add to your soil. And I think you need to be very, very careful. I think that you should not add any of these items here to your soil unless a soil test says you need them, because you can very quickly get out of balance with some of these elements, and that is not good. So, and I want to point out gypsum. We hear a lot about gypsum, and a long time ago, in the 70s when I worked, I would recommend gypsum to people for clay soil. It will break up the clay soil. It will open it up. Well, yes, it will do that in our area, but only very temporarily. To open up clay soil, you really need organic matter. Gypsum to open up clay soil is appropriate for sodic soils, areas in dry lands, very, very dry lands. That's where it's appropriate. Really not here. So please do test before you add any of these and to make sure you need them. And here's an example of a test of some topsoil. And it's kind of, I just thought I'd show it to you real quick. What you're going to see a lot of times on tests was you'll see the salinity, you'll see the sodium level, you will see boron. Boron and sodium are problematic in soil. Boron, you need just the right amount, not too much. And same with sodium. Too much sodium, it's a problem. Then you will see the pH. That's always that's interesting to know. The plant available macro and micronutrients. This can be very deceiving because a soil is testing them in a soil lab. They're testing them using bases and acids, and it's not something that you would find in your garden. A soil test is sort of a snapshot in time. I might do actually, to be honest, I have never done a soil test. We have never done a soil test in our own garden. But you might want to, if you're having problems, you might want to do a soil test and just see if you're really out of balance somewhere. Or you might want to do a soil test at the beginning when you're just starting to garden, and then maybe a year later around the same time. A soil test is just a snapshot in time, and it's only as good as the sample you take. They don't always show nitrogen because nitrogen is very elusive. It changes very, very quickly. They will usually show the total cation exchange capacity, which is interesting to know. That's sort of your savings account of how much calcium, magnesium, and potassium your soil can store. It will tell you how much organic matter is in your soil. That is really interesting to know, and I encourage you, if you decide to do a soil test, have them test the organic matter for the C to N ratio so you can see where that is. And then the soil texture, and this happens to be a sandy loam soil, and there also happens to be a little bit of about 10% gravel in this soil. So to kind of end the talk, I'm going to go over planting tips because I really feel this is so important for us to understand how to plant trees, bushes, and shrubs. I think there's a lot of misunderstanding on this, and UC Davis did a study on this and found that you should not amend your backfill soil. You should use the native soil. And why? Because your plant is going to grow in that soil and you want the roots of the plant to move out beyond the planting hole. And if you make this perfect little soil mix in your planting hole, chances are your plant may not move out. Therefore, the plant is not going to be really solidly established in the soil. And in a windstorm, it might just fall over. So dig your hole at least 3 times wider than the diameter of the pot, but no deeper than the height of the root ball. If your soil is compacted, make it wider, a lot wider if you can. And break up the sides of the planting hole with a pitchfork or a shovel. And maybe take a pitchfork and put in the bottom of your hole and move it back and forth just to open it up a little bit. And then do soak the root ball and the planting hole before planting. Root balls, if that root ball dries out, it can become hydrophobic. And it may not re-wet. Even if your planting hole is wet, if the root ball is dry, it's very difficult. Water is very, very interesting. So make sure that root ball is nice and moist. Then plant your plant, making sure that the root flare is slightly above grade because your plant is going to settle a little bit over time. And then backfill with your native soil, compressing lightly with your hands as you're going and watering lightly. And then put a thin layer of 3/8 or so compost and then cover with mulch and water slowly. But keeping in mind to keep the compost and mulch well away from the base of your plant because your plant needs good air circulation. Anyway, I really encourage you to consider using this practice next time you plant. So now just showing you a few garden pictures. This is a 1960s Japanese garden under oaks, and it was ferns and azaleas and lots of water-loving plants, and it's now becoming a waterwise garden and transitioning to native plants. The oak tree was, very popular back in the 70s to put cobbles all underneath the oak tree. Not a good idea. If you have cobbles under your oaks, please remove them and allow the mulch from your tree to fall onto the soil. That will be the best for your oak tree. And then this was a weed patch and an annual grassy weed patch. And this is where we did the modified sheet mulching method. And now it's a California native garden, brings in lots of pollinators and beneficial insects, and hummingbirds. It's really a delight to watch as it changes over time. And this is Lisa Putnam's Mission Farm, deep soil, very deep soil. I've gone out there and I bet I've gone out there with a probe and you can just go down and down and down into that soil. It's really amazing. And this was done with cover crops for many years. I don't even know how many years, but Lisa's been a master gardener since 2009 and I believe she was cover cropping prior to that. So it's really an amazing garden that shows that plants and the soil community and soil structure can really take care of your veggie garden. There's not a lot you have to do except make sure that you're, feeding the life in the soil, that carbon with your plants, and protecting against compaction and growing all year long. And then this is Shilpa's raised bed garden. There are many, many ways in which you can do many design options for raised beds. And raised beds are really great because you can set it up in a place where the conditions are right in terms of the sun and in terms of tree roots, invasive tree roots. And then you can bring in a soil if you want, and you can have it at a level that's comfortable for you to garden in. And you can put down gopher wire to protect if you've got gophers. Now remember, I don't hate gophers because they do such a great job of picking up soil, but you really don't want them going into your eating all your plants. So, and then I just have to get near the end to talk about pollinators and beneficial insects and how important they are to invite into our garden, and it's our plants that are inviting them in. So really get familiar with what plants invite in, what insects, and get curious about all the insects out there. Get to know them. A lot of times you may be shocked at what they do and how good they are. This happens to be a very early morning photo. It doesn't look like it, but it was like 6 in the morning, and that's a little checker spot butterfly spending the night on a Matilahae poppy with a little native bee. I thought it was very sweet, so I had to take a picture and share it with everyone. So protect and build soil structure. That means plant cover. That means mulch, but leave some space for your native bees. And that may also mean a diverse cover crop. So the soil plant connection, sunlight drives the system, know your plant's needs, protect the soil from the elements with good plant cover or mulch, saving space, but keeping some areas clear for your bees. Good soil structure means good water infiltration, and that is so important. Feed the microbes, leaf litter, compost, mulch. Let the microbial community and plants feed each other and support the larger community. Really, it is a huge ecological system, and all these, it needs us so much right now. It needs us to really grow the plants and provide what is needed so we can support all these wonderful beneficial insects and pollinators. So thank you so much for listening. I really appreciate being able to share this with all of you. And now I will stop sharing, and I'm ready for any questions.
So Terry, lots of questions came in during the last part of your presentation. And the first, I'll just go in order that they arrived. The first one was from Kathleen Putnam saying, I've been told certain plants, brassicas and blueberries, don't have mycorrhizal relationship. Do you think that's true, or have we just not found it yet?
Kathleen, I know. Well, I don't know, Kathleen. There's so much we're learning, aren't we? And it's amazing. Every day, science is learning more and more and more. So I don't know that we have an answer to that, do we? But it's a great question. But they do appreciate the soil structure, and if there is any sort of relationship, the more you can support soil structure and microbial community, then maybe someday we'll find out, yeah, that's all going on. We just didn't see it.
So another question came in from Barb William Sheng, and she said, should weed roots be left in the soil? I think you did say something a little bit later in your presentation about that.
Yeah, so weed roots, if they're annual weeds, yeah, leave them in the soil. You chop them off, and you can probably leave them in the soil. watch and see. They are providing food for the microbial community, and we've done that in our own garden with the annual grassy weeds. We just left all the roots in the ground and put a little layer of compost over the top and mulch over the top, and that really took care of it pretty good in our garden.
Then we had from Trisha asking, is rice straw a good mulch?
Yeah, yeah. If you can find it, it is also a good mulch. It's going to take a while to break down, but yeah.
Um, from Annie Lewis, I'm having lots of root problems with roots in my raised beds. What about root barriers?
Yes, I didn't mention it because I don't have personal experience with it, but I did look into it in regards to Bermuda grass, and it seems that root, those plastic root barriers can work. I just don't know how deep you have to go into the ground. I think it's probably at least 3 feet. So, yeah, it is a real challenge with tree roots because they love that raised bed soil.
So Kathleen Putnam also added that boxwoods will invade a raised bed as well. We had Trisha Jordan again asking, how far do redwood roots travel?
Ah, I had an experience with redwood roots that was amazing, and I think they will travel quite far and they will get quite large. I can't say exactly how far they will travel, but they will very quickly totally fill in a raised bed. And I had a small pond in my garden with redwood trees, maybe 30 feet away or 50 feet away, and those roots completely filled in the pond filter and completely plugged it up. It was amazing, and they were big and very fast. So I don't know the exact amount of feet. And in this case, you might want to do a little investigation, see if anyone's done any studies on how deep you need to go with a root guard, but you might want to put something in because they really love raised beds.
Okay, and Kathleen asked, if you cover crop, do you still need to add compost and mulch?
Oh, Kathleen. No, you don't have to. You do not. If you cover crop, you don't have to add mulch. And as I was saying in the presentation, cover crops are feeding the soil and feeding the life in the soil. And you probably don't have to add compost. I believe, Kathleen, that you and Lisa I don't think Lisa adds much compost at all anymore in her garden. I think it's all being cycled by the nutrients because you've got plants growing there all the time. So
Okay. We had a question from Anne asking how to best chop up fallen leaves on on her property. How small to chop them?
the smaller they are, the faster they're going to break down, and it really kind of depends on the leaf. So for me, oak trees, I don't really worry about them. They're fairly small leaves. For things like big leaf maple, it's probably nice to chop them up, and uh, I've heard some people, I have not done this, I've heard some people run a rotary mower over the leaves and break them up that way. If you have a little shredder, you can break them up that way. Yeah.
Becky asked if you could talk about oxalis.
Yeah, oxalis, it's so pretty. Um, it's a tough one. Yeah, because there's all those little bulblets down in the root zone. So when you pull it out, you actually can be creating more of a problem. I don't have a lot of personal experience with it. At my husband's house in Oakland, as I remember, we put in a native garden there and we had oxalis and we cut it down at the base and then we did a sheet mulch, and I don't remember it being a problem after that. But one thing I will say, with a lot of oxalis or bindweed, we have a huge bindweed problem at our home now. And okay, I froze. Can you hear me? Okay. Uh, uh, the bindweed, what I notice is now that we have natives growing in, the soil is changing and the bindweed just isn't a problem anymore. So as you change your soil and start building that soil structure, a lot of things that were weedy problems, are really a problem for you, start to go away.
Lisa Putnam did just add a note about the grinding of leaves. She said, make sure you are careful about the timing of that so that you're not hurting any of the insects,
Oh,
the
very
beneficial
good.
insects.
Thank
Yeah.
you, Lisa. Yeah, yeah.
Barb asked a question about rock mulch. She said, is small rock better than the larger river rock?
You know, small rock is definitely going to be more likely to move in and, mix in with your soil underneath. It can settle down into the soil than larger rock. In terms of as a mulch, I don't really, it's easier to get good coverage with a small rock. With larger rocks, it's a little bit harder. You need more rock, and you have to go deeper with a larger rock than you would with a small rock. With a small rock, I don't have a good way for it not to mix in with the soil other than to say put down base rock and compact it and put the rock on top of that. And that you don't want to do in if you're bringing it in for a native garden that prefers a more sort of Southern California approach. So it really just depends too on what your soil texture is.
Mhm. So Terry, when I see trees that have big rocks around the base of the
Oh
tree,
yeah.
I think that's not a good thing for water percolation, for air. And then sometimes you see it and you would think that the rocks get really hot and they're drying out the soil and killing the microbes. Does that happen with these really big rock coverage?
Well, I think, like for instance, when I was talking about the oak trees and with the cobbles, that was very popular to put cobbles underneath oak trees because we became aware at some point in the 70s maybe that oak trees prefer no irrigation in the summertime. And so, okay, then we're just going to put rocks down. Well, these cobbles will break the fall of rain, so they will do that. They will guide the water into the soil. They are not providing any nutrients to the soil microbes. If they are out in the hot afternoon sun, they will get hot. I don't know how far that heat is transmitted into the soil, but for sure, soil microbes do not like, I forget at what temperature it is. I used to know this, that you end up, solarizing them. So it really, a rock mulch is appropriate for certain plants that live in more dry climates and generally have a more sandy soil, not a clay soil. So they aren't going to move down into that soil. They're going to more sit on top. So it depends, as so many things are.
Okay, we had a question from Lynn Trujillo. What is the ideal uh, carbon to nitrogen ratio for a raised vegetable garden bed?
Yeah, so ideal would be, I didn't say this, did I? So thank you for asking. Ideal would be somewhere probably around C to N of 20 to 1 or so. Yeah. Yeah, 20 to 1. You don't want it to be above 30 to 1. 30 to 1 is then getting over into the little bit too much carbon. But I think that our focus is so much on nitrogen, and we really need to pay attention to carbon too. So sometimes just applying that carbon, maybe a little bit on the surface of the soil, is another way.
Mhm.
And
So
letting the
this is,
microbe, working it in. Yeah.
thank you. So they like cured compost is kind of that in that range. Is that right?
Compost can vary, like animal manure, like especially poultry compost, turkey compost can be 15 to 18 to 1. And then sometimes horse manures can have a very high C to N. They can sometimes be above 30 to 1. So you just, yeah.
Well, that's a good lead into the next question, which was, I have a compost pile at home. I've had it for about 20 years. I add my backyard chicken poop to it. Is this a bad idea? I let it ferment for at least 6 months after adding the last batch of chicken poop before adding any plants or soil.
I think that's great that you're composting it. I would wonder if you need a little bit of carbon to add to it, if I would wonder about that. Um, After 6 months and you're adding it to your garden, if your plants are not reacting negatively to it, then it sounds like you've got a pretty good compost there. But I would wonder about if it wouldn't need just a little bit more carbon, and maybe you have some leaves in your garden that you can shred and add to that to add to that manure.
And Catherine Fraser asked, what about worm castings?
Worm castings are fabulous. They're wonderful. They are, worms are just like, they have little inoculation chambers in their guts, and so those castings are filled with all kinds of life, and they're really good to amend use as a compost or even by themselves in your veggie garden.
Okay. I did send out to everybody your resource for home tests, and it looks like 2 of the 3 links worked really well. One was took the person to an error page.
I'm
So,
sorry.
so we
Checked
may
all of
have to
those.
circle back
Yeah.
to make that change before this is put on YouTube. And then let's see. We had a question from Thomas. Is window cured to organic standards compost made from horse manure and straw bad for microbes or mycelium in soil? Is it okay to use as a
I'm sorry, I didn't
use it
quite
as a soil
understand
amendment?
that.
Let me see. Window cured. Sorry, I'm trying to reread it so that I can make sense of the question. Window cured to organic standards. Compost made from horse manure and straw, is it bad for microbes or mycelium in the soil?
Compost made from horse manure and straw. It kind of depends on what was going on for the horse. And if it was, I know horses, they need medicine. So I would find out what went on with the horse in terms of what kind of meds or sort of have been given to the horse that that could make a difference, and it might require that compost needs to cure a little bit longer. It's always good to know, sort of as much as you can.
And Thomas, thank you. If I didn't represent that question well, please add something to the chat. My apologies if that's the case. Oh, Becky Fishback, this is such a great presentation. Thank you so much.
Oh, thank you.
She asked if the recording would be available to watch. And I think Lynn mentioned something at the beginning. We would be putting it on our Master Gardener YouTube site. Okay. Excellent presentations. Let's see. Can someone please? Oh, can someone please save the chat?
I got it. I'm all set. Thank you.
Okay, thank
Yep.
you. Thank you very much.
Yep.
I'm not sure I can do that. I can find maybe the right person in our group here who can.
I can forward it. I can forward it to somebody too.
Thank you
Yeah,
so much for
welcome.
your help with that. Wonderful presentation. Let's see, redwoods. This is a long shot. I have a small redwood tree that I would like to donate instead of chopping it because it is near the house and is a fire hazard. Is there a place, Foundation University, that would like one tree? Gosh.
Yeah, I don't. And to donate the living tree and dig it out, I don't know. I don't, I really don't know. I wonder if Kathleen, do you know?
Kathleen Putnam, you're probably, your audio's probably blocked.
Oh, yeah.
You can unmute yourself.
I don't know anybody who would want just one tree.
Yeah, yeah. And digging it out would not be very easy, would it?
No,
Yeah,
you
yeah,
couldn't get a good
yeah.
enough root ball that it would
Yeah.
survive.
Yeah, yeah. Thank you, Kathleen.
Kathleen, I have another question for you. Does sandy soil have no cation exchange capacity?
Yes,
Oh,
it does. I'm sorry, but organic matter, and you can get it, you can increase it with organic matter quite a bit. So you can make a big difference there.
And I think our last question, Ann Lewis, sometimes, sorry, she's just commenting that sometimes redwood saplings are used for memorial trees.
Oh, okay.
So those are the questions that have come in from the chat, Terry. I think unless anybody has anything else they would like to quickly ask and put that in the chat, I'll just keep an eye on it. But I think otherwise we're done with the question answer period.
Great.
Thank you again, everybody.
Thank you.
I think we are at the end, and Kathleen, or no, let's see. Oh, Kathy, you dropped in, I think.
Yes. Kathy, I think you're muted.
No, there we go. I found it. I just wanted to thank everybody for joining us today. It was such a pleasure to share our great treasure, Terry Lyngso, who knows so much about soils. I learn something every time I see her. And I also want to invite you to our spring garden market. UC Master Gardeners have their annual plant sale and education fair. I have screen sharing right now. I think you can see it right there. It's Saturday, April 19th, coming up soon. It's at the San Mateo Event Center at Sequoia Hall. And that goes from 9 a.m. to 1 p.m. And we used to call it the tomato sale. And now, of course, we have all kinds of wonderful things, including tomatoes and natives and vegetables and succulents and pollinator plants. And so we would just be thrilled to have you come and take a look at what we have to offer. And we really would welcome you there. So thank you for coming today and hope we see you on the 19th. And Terry, thank you so much. I appreciate all you do. And I learned so much. I have a little bit of pangs of guilt of all the things I should be doing. And I'm going to go to my garden and start working.
Don't do that.
My microorganisms in the soils will thank you.
Thank you, everyone. It was great talking with everyone. Thank you.
This was fun and great questions too. Okay.
Great. Thank you, everybody.
Thank you so much.
Bye.
bye.